Welcome to today's webinar that we hold together with AWS Modernizing Legacy Operations with Containerized Solutions. And with me today, we have two people from AWS, Daisy and Jo-Young, as well as two of our kreuzwerker consultants, Katharina and Sharif. After a very little intro to kreuzwerker, I will hand over to Daisy. She will brief you a little bit on ECS and Fargate with a short overview. After that, we'll have Jo-Young with a quick demonstration. And then we'll close today's session with a case study presented by Katharina and Sharif. So kreuzwerker has basically founded in 2012. We're an AWS partner basically ever since for nearly 10 years now. We're fully committed to AWS and all the things and services that we do. We do have offices in Berlin, Frankfurt, and Munich in Germany, as well as in Warsaw in Poland and Zurich in Switzerland. The services that we provide center around migration and modernization. We do provide services for data and analytics. We do a lot of cloud-native software development and help our customers modernize their application landscapes by using AWS native services such as serverless. We provide managed security services and do a lot of cloud financial management. Currently, we're an advanced tier service provider of AWS. We employ over 100 certified experts across all the different services that we provide. And we do partner in a lot of like different competencies and programs of AWS. And we're basically the first one in the DACH area who achieved the DevOps competency. So without further ado, I would just like hand over to Daisy.
Thank you so much for the introduction. So let me jump into going over what ECS Fargate is and sharing my screen now. Hi, everyone. I'm Daisy Devskaya. I'm a senior GTM container specialist at AWS. And today I'm going to cover a little bit about ECS Fargate. So give you a quick introduction and an overview into what ECS is, what Fargate is. And then we'll jump into some of the releases that we did in the past 12 months. And then I'll cover a little bit of roadmap items, things that we're looking to implement in the coming year. And as always, you know, roadmap items are, they tend to change from time to time. So for the overview, you know, when you think about ECS Fargate, it's really giving you that capability of a fully managed control plane that's easily deployable, manageable, and scalable for your applications that are containerized. So ECS and Fargate really combine well to give you a fully managed experience where you don't have to worry about all the heavy lifting of doing like patching and maintaining your AMIs, and clusters and things like that. So it's really saving you big deal on operational overhead. Also, there's no container host to manage, so it's easy to scale, and you can better utilize your containers. And you know, if there's things like cost savings that's top of mind for you, we have things like Fargate Spot and savings plans that can really help you reduce the overall cost of usage, and also be more doing more scrutiny into how you're spending using the resources at AWS. So if you look at the core features and structure of ECS, it's really giving you that capability of going and creating your own tasks. So you can create one or multiple tasks that will be logically grouped into services. So services, think of it like a sort of a bucket that contains multiple tasks, and each task can have one or more containers. And then the service then, you can have one or more service into a cluster, which is a grouping of services and tasks. So deployment is really done in steps, you know, create your cluster, create your task definition. That's where you define all your containers and what tasks you want them running on. And then you create your service. So the next step, once you have all your tasks defined, is really now provisioning your containers and your services using container images. So this is like a very high level, what ECS is, and maybe some of you have already used ECS in the past, so this could be more of a refresher. So again, just to give you a quick overview of ECS and Fargate. So Fargate, ECS being fully managed, there's no middleware to install, upgrade, and it's free of charge. And you only pay for the underlying, EC2 infrastructure that you use. And then if you choose to use Fargate, it's a serverless container engine. So there's no OS to upgrade, to patch, or secure, and it's very secure by design. So the isolation model that's present in Fargate really allows you to securely leverage your containers. And it has, it's very simple and it's really fast. And we have something building called auto-scaling that helps you not only save on costs, but it's also a great way to scale up and down depending on your needs. So looking at some of the releases that we did in the past 12 months, the first one being AWS Compute Optimizer. Computer Optimizer is a great tool, especially if you're very interested in looking at your costs and making sure that you're only right sizing and using what you need. So Computer Optimizer gives you a predictable view of how much you're spending on your ECS Fargate. So you can see each of your tasks and your services and see what is the consumption that you're making there and how can you either downsize or upscale or scale up to really have that right sizing in mind. So it gives you predictions also, and you can really drill down into past months and how you've been leveraging your containers. Then we have increased Fargate's configuration size, 8 and 16 CPU combinations. That's something that our customers have been asking for a really long time, and it helps with workloads like batch workloads, extract, transform, and load jobs. We've seen applications where customers use it for like genomics and media processing and things like that. So that's another feature we've released recently. We increased our task launch rate improvements within the past 2 years. So it's been a top request where Fargate, our customers wanted it to be even faster than what they're leveraging today. And that's a feature we released where now you will notice the difference of speed in Fargate compared to what you were using ECS on EC2. The service codec transition, so that's something that's done automatically if you were already using containers on ECS and Fargate. But now you can opt in or opt out of having your pods and tasks automatically transition to that new number of CPU-based processing. And then last but not the least, there's improvements to our disk utilization metrics monitoring. So now you'll be able to use things like CloudWatch to do a deeper monitoring of your task ephemeral storage, which before, you had to manually configure that. You can have access to that through CloudWatch and Container Insight. So I'm going to very briefly touch upon some of our roadmap items. And roadmap, again, is subject to change and it's under NDA. So the new capabilities that we launched are more or less categorized in different areas. So first one being our customers now have like the flexibility, will have the flexibility to use more intelligent imaging using Linux. And then we have buckets like security, efficiency, and operational excellence that are also in the works. So I'm just going to touch on a few of them, like performance. Some of the items here already released, like the faster task start times, consistent compute and networking. So greater performance across Fargate. So really focusing on how do we increase the performance even more than we have in the past 2 years. Also reducing price for Graviton. So we didn't talk about Graviton today, but Graviton is a great way to do cost savings. It's an ARM processor-based CPU that you can leverage alongside the ECS and Fargate, and that gives you an additional savings on in your bucket. So we're doing even more reductions if you were to adopt Graviton, and we're going to include additional regions, including Mumbai. Security, so there are some enhancements coming up to security. Like you can see here, additional Linux capabilities for runtime security monitoring. We have FIPS 140-2 compliance coming up for cryptography, and secure ephemeral storage with CMK. So that's about it for an overview of ECS Fargate and roadmap. So I'm gonna pass it over to Jian.
Yeah, hello everyone. My name is Jian Kim. I'm a container specialist, solutions architect at Amazon Web Services, and I've been working at AWS for around 3.5 years. And I was living in container world, yeah. So, but especially nowadays, a lot of my focus is Amazon ECS and AWS Fargate. And I also team member with Daisy, and happy to meet you guys. So today I'm going to explain about ECS Blueprint, which is a collection of infrastructure as code. Also, we can shortly say IAC, that help you configure and deploy container workload on the top of ECS cluster. So customer can use ECS Blueprint not only for beginning ECS journey, but also for building specific workload like a front-end service with application load balancer on the existing cluster. And I'm gonna briefly explain the motivation for ECS Blueprint. And the essential and core object is definitely for accelerating customers' journey on ECS. So nowadays, containers are as de facto standard for packaging and deploying applications. However, for many customers, the learning curve and skills needed for containers can be quite steep. They have to run container image building, and they have to understand the container orchestration tools such as ECS and EKS. Then also they have to figure out creating deployment artifacts, yeah, that kinds of thing. Also, you have to consider about which CI/CD tool are you going to use, and also think about which monitoring are you going to use, and also consider some security stuff when you're designing ECS workload. So I would say, even though containers is emerging technology and also almost standard technology nowadays, but still it has a lot of things to run. And even if the aforementioned items are reserved, we have another homework left, which is ECS and Fargate. And like Daisy said, ECS and Fargate is easy button for starting container workload because a lot of things managed by AWS rather than you guys. But there is still quite a broad set of skills that the new customer need to ramp up. So yeah, here is the few of the question that you have to think about when you're starting ECS and Fargate journey. So at very first, you have to figure out what is ECS and what is Fargate and what is the key components in here. And also, how can I set up some IAM rules, or how can I combine this ECS cluster with other AWS services? Yeah. So with ECS Blueprint, we want new users or existing users to achieve benefit of container-based modernization in hours rather than months. So the blueprints are meant to give new users a jump start and enable them to run by doing. So with Blueprint, we aspire to codify best practices, well-designed architecture patterns, and provide end-to-end solution addressing CI/CD, observability, security, and cost efficiency. And ECS Blueprint shows the best practice for each scenario and provides reference architecture and solutions pattern. So in here, I'm gonna show you sample architecture which covers in ECS Blueprint. So we have a lot of ECS Blueprint template in our ECS Blueprint. The first thing is core infra template. So this contains not only for ECS cluster, but other basic AWS services like AWS VPC and CloudWatch, and for ECS service discovery for the cloud map and some IAM stuff things. So by making this one like these two, the IAC tool like Terraform or CDK, then you can easily deploy same pattern with every region. So this is one thing in ECS Blueprint. And second thing, we also made some backend service template. Yeah, so this is usually for some backend API, so not attached into, not directly running behind the load balancer, but yeah, usually placed in private subnet and yeah, do some API requests and then yeah, after that response back to the customer. Also, another template we have is a front-end service. Yeah, so when you think about three-tier web application, yeah, usually this one might be a web-based API or some front-end side like JavaScript or HTML stuff might be also good example. So in here, we already made some template like when you provision this front-end service template, then it will definitely provision application load balancer as well as some front-end AWS Fargate. So if customer send some traffic into the application load balancer endpoint, then it will toss that traffic into this AWS Fargate. Also, when you're building container workload, then building CI/CD pipeline might be definitely mandatory. So we also made the CI/CD service template, and you can see in here, when you make some code and then push it into your remote GitHub repository, then AWS code build container image and build related artifact, and then store that thing into the Amazon ECR. And after that, after the whole building is finished, then it will deploy new container image into your ECS cluster. So we made that common, these kinds of template, which is usually used for a lot of customers. So I'm gonna briefly show you ECS Blueprint repository and the example in our AWS Management Console. So as you can see in here, yeah, there is a ECS Blueprint repository. Yeah, and this is the public one. And sorry, in here, there is some sample application code, and also there is a CDK part and there is a Terraform part. And in terms of Terraform, a lot of people using, since a lot of people are using Terraform rather than CDK, yeah, a lot of people use Terraform example in here. We also make some ECS easy to example and ECS Fargate example in this folder. And in module, we made some code build and code deploy example. So you can easily use this like some code library stuff, or you can easily say this is kind of library or function. And jump into the Fargate example. We made a couple of examples that customer usually using in our ECS. So at very first, I was told you there is a core infra. Yeah, it definitely need when you just start the ECS journey. And there is a front-end service example. And also there is a queue-based processing example. A lot of people who use data processing workload on ECS, they usually make some SQS and then push some queue into there, and they expand their ECS Fargate or some computing resource based on their queue length. So we made some sample example in here. So if your queue length is more than 300, then it definitely increase Fargate like more than 2 or 3. So that is the one common example. So I would say you can definitely see, you can definitely explore these things. Also, nowadays, a lot of people asking about Graviton things because it is really cost effective. So some people, hey, I'm not currently using Graviton, but I also want to explore this. So based on customer taste, we made this example. So as you can see in here, all you have to do is just push your sample code. Then this Terraform template will build some code pipeline with multi-architecture code pipeline. So it will build not only x86 architecture, but also build the Graviton, ARM processor thing. And then store, build, manifest in ECR. So after that, you can easily pull x86 as well as ARM processor in your ECS cluster. And testing this thing into the develop stage. And then if everything seems okay, then you use Graviton stuff into your production level. So you can explore a lot of example in here. And also, we provide CDK stuff in here. So you can also considering CDK, then you can see this example. And still we are explain whole instruction into this ECS repository, but I think sometimes it's a little bit hard to start because some instruction is a little bit confusing. Then there is a workshop studio material in here. So you can just follow this instruction. This is definitely same with ECS repository instruction, but we add more detail in here. So I think you can easily follow ECS blueprint with these workshop materials. And I'm gonna show you a little demo, like 2 or 3 minutes, and hand it over to other presenter. So in here, I used the ECS blueprint for CDK, and as you already know, CDK, when you provision CDK stack, then cloud in the behind the scene, cloud formation will work. So I provisioned core infra stack and backend service and front-end service in here. And as you can see, jump into the ECS console, and there is a cluster which name is ECS Blueprint Infra. And you can see 2 services in here. So one is backend and the other one is frontend. And there is the number 3 per 3 means this is the desired number of this service, and this is a currently running number of these services. And this ECS task tied with the ECS services. So you can see all the ECS task entities in here, and these are the status and latest status. Also can see which task definition are you currently using. This task definition means you can define a whole bunch of things like which container image are you going to use and how much CPU and memory resources are you going to allocate this ECS task. Yeah, and which IAM role are you going to use. That kinds of thing is covered in this task definition. And this ECS task, which is associated to the task definition, and also one of the part of specific ECS service. You can click in here, you can see a lot of configuration and information regarding this ECS task. So since my front-end service running behind the load balancer, when you click this ECS demo front-end, you can also figure out application load balancer information in here. So I'm gonna click this load balancer and jump into the DNS name. You can see full stack application. This is the ECS demo frontend, and this is the ECS demo backend. Yeah. So with ECS blueprint, you can define some sample template. After that, then you can easily roll back into that infrastructure. Or if you're considering some global workload, then all you have to do is just build that sample template and deploy to the German region or United States region. Yeah, you can reuse those contents. I think, this is all I have to share today. So I will hand it over to other presenter. Thank you.
Thank you very much for your presentation. Without further ado, I would then hand over to Katharina and Sharif from Kreuzwerker, who will guide you through a little customer example that we did recently. There we go. So welcome on stage, Katharina and Sharif. Stage is yours.
Quickly, hello everyone. My name is Katharina, and today we would like to share with you how we address data synchronization challenge for one of our clients by implementing an event-driven and serverless ETL solution. So let me briefly introduce our client, a prominent company operating in a field of clinical diagnosis and research. They are known for their strong emphasis on data-driven approaches, and their researches are fueled by the Biodata Bank, which contains an extensive collection of data from over 500,000 individuals. Given their primary focus is on laboratory operations and diagnosis, the client has a limited expertise in software development and implementation, and this is actually where our role becomes crucial. The task assigned to our team was to design and implement a cloud-native serverless solution to automate the synchronization of data between various systems within client's organization. This task was crucial for them in streamlining their business processes and achieving seamless data integration across systems. Our client utilizes multiple systems to support different aspects of their operations. Among those is a web shop used by customers to browse and purchase products, customer relationship management system used by sales team, enterprise resource planning system to manage billing and finance related actions, laboratory management system to support and streamline their laboratory operations, and many others. And each of these systems is managed by external provider, third-party provider, and data that includes an information regarding the product sold in our customers' web shop, and also all customer-related information was duplicated and overlapping across the systems. None of the system as well had an exclusive ownership of the data, leading to data inconsistencies and discrepancies. And like one of the reasons for data inconsistencies was often also missing real-time synchronization between different business processes. Having said that, today we would like to look in detail at one specific use case, synchronization of the product-related information, and what had to be done to achieve it. So for each product in the system, the relevant data needed to be extracted from a specialized tool, master data management system using REST API. This system will become the owner of the data going forward, ensuring its accuracy and reliability. Due to the complex and hierarchical structure of the data, various aggregations had to be performed to transform it into aggregated and agreed upon format that will be used by target systems. And transformed data had to be seamlessly transmitted into target systems using REST APIs. The design of solution was strongly influenced by a set of qualities and requirements that it needed to meet. The solution had to be designed in a way that minimizes the need of maintenance and manual iteration. It should be easy to understand and operate. The solution have to be able to detect and manage errors gracefully, providing appropriate notifications or alerts when issues occur, and it should be capable of automatically retrial failed synchronization attempts. As already mentioned earlier, the solution should seamlessly integrate with external systems via REST APIs, and it needs to be capable to handle large volumes of data efficiently and parallelized processing of a product data, enabling simultaneous transformation and synchronization into multiple target systems. Lastly, the solution have to be adaptable to real-time synchronization solution once external system incorporates support for it. And now I would like to hand over to my colleague to introduce you to the solution itself.
Thank you, Katerina. So let's have a look at the architecture. In addition to the commonly known API gateway and Lambda functions, the solutions uses two more serverless AWS services, Event Bridge and Step Functions. Event Bridge is used for choreographing the event flows. You can create an event bus to receive events emitted by various resources. And to manage these events, you can create rules that watch these events, match it against set patterns, and then send the matching events to one or more targets. Each rule can have up to 5 different targets. The second AWS service involved in this solution is Step Functions, which is used for orchestrating workflows through the use of state machines. In our case, we utilize Step Functions for its map step. The distributed processing mode of a map step lets you run up to 10,000 parallel child workflow executions to process millions of data items at one time. And we used it to extract and transform all the products simultaneously. And now that you know what services are being used, let's look at the entire workflow. The entire workflow is divided in 3 smaller workflows triggered by 3 different events: sync triggered, product IDs fetched, and product fetched. Let me explain. With a manual trigger, an API is called, which puts this initial sync triggered event to the event bus. From here, a rule matches this event and invokes a Lambda. The responsibility of this Lambda is to communicate with this talent MDM system where all the products reside and fetch all the product IDs of all the products inside a container. All these product IDs are collected and put back in the event bus with a product IDs fetched event. This event again is matched with a different rule. And this rule invokes a step function. This step function has a distributed map step, which invokes this lambda for all the products at once. For each product or the ID of a product, this lambda communicates with talent MDM to extract the product information and transforms it to the desired format. It also publishes each product. Sorry about that. Each product is published back to the event bus with a product fetched event. So of course, you are going to have as many of these product fetched event as many products exist. And for each event, we use the API destination feature of the event bridge to send the product to the target systems, which in our case are CRM and ERP. So now that you know what steps are involved, remember the North Star that my colleague Katrina was talking about earlier. Let's have a quick look again to see how this solution aligns with those requirements. So low maintenance, since we are using managed serverless services to choreograph the flow, it's low maintenance. The event flow is simple enough to understand with the aid of proper documentation. For the third point, using the event bridge gives us out-of-the-box error handling and retry mechanisms. We also set up alerts so that we get notified if an event ends up in a dead letter queue. Using API destination, the API destination feature of Event Bridge helps us effortlessly integrate with external systems. And the distributed map step of the step functions helps us transform the bulk of products in parallel. And finally, since the workflow is now divided, in future, we can simply put one product ID with this product ID's fetch sync in real time to make sure that only that product is synced in real time, eliminating the need of this manual trigger. So, while discussing the North Stars, we already covered most of the benefits. Let's have a look at some of the trade-offs. Number one is it requires all target systems to be idempotent because the order of the event is not guaranteed. And second, it can be challenging to visualize the entire workflow without adequate documentation. Unlike the step functions, which comes with built-in visualization of the entire orchestration flow, for Event Bridge, visualizing the flow needs to be done separately. So if you are planning on using this solution or a similar solution, make sure to have a plan to mitigate these risks. And with this, I'll hand over again to Daniel. If you have any questions, please post them. Thank you.
Yeah, thank you very much for the demonstration that we saw earlier and for the case study that we've seen today. So if there's any questions, please feel free to put them in the Q&A box. Otherwise, we will definitely be sharing the links that you've seen, so the examples as well as the slides afterwards. And feel free to pop your questions in the Q&A. I would just like give you a brief overview of the relevant solutions and services that we as Kreuzwerker offer in that area. So if you want to get started with assessing your serverless journey towards AWS, or if you already have running workloads on AWS, then we can definitely support you by running either a serverless readiness assessment, by seeing how your current stack will perform and how much we can actually migrate or modernize in regards to using AWS native services that are serverless, such as the ones that we've seen today. We can analyze your workloads by running a well-architected framework review that will just like simply analyze all of the different aspects across the pillars of the AWS well-architected framework. Both of these offerings come at a free price, and you will basically get a review afterwards with a lot of findings that you might either remediate or can base a modernization strategy on. Also, if you already have identified certain workloads that you want to modernize, we can support you in building either proof of concepts or simply implementing cloud native solutions using AWS native services. So if any of this is interesting for you, this is basically how these offerings will come to you. They're usually low cost. They are kind of proven by many customers so that they're repeatable. We're happy to send out these one-pagers to you afterwards if you want. So please feel free to get in touch. Thank you very much for your attendance, and hope to see you soon in any of our following webinars. Thanks a lot. Also to the folks from AWS who joined us today. And then have a good day. Take care. Bye-bye.